Welcome to your first video on our unit on trig identities. This is meant to be somewhat basic, this first video, just going over a few of the formulas that we have on the very top. So we're going to look at the reciprocal identities, which hopefully you're used to, the idea that cosecant is just 1 over sine, or sine is 1 over cosecant. You see the other four that are left in this area. And then also to look at the quotient identities, which is just saying that tangent is sine over cosine, or that cotangent is cosine, and that should say over sine. So hopefully on yours that change has been made already. But the fact that this should really be sine of theta. And as we go through this unit, I think that's important to note that in our notes we use theta. A lot of times in some of my examples I'll use x as the angle. So whether it's theta or x or y or some other sort of symbol, they basically all mean the same thing. But our job in this entire unit is to simplify or refine or re-express different expressions using all kinds of trig ideas. And I think this first video will be definitely the simplest that we look at, and just a good introduction. So if we scroll down to a few new ones, let me erase what we have there. And as we scroll down, we look at our couple of examples from part B here, the basic questions that we have. What does it mean, or is it true that cosine times secant equals 1? And as you would go through and kind of figure this out, I kind of hope that you realize that this is true right now. But as we would go through and write this out, maybe one step we would take is to say that cosine is pretty simple already, so let's just leave that the way it is. But secant, if we go back up to the top and look at our rules, that's the same thing as 1 over cosine. So we just replace that secant of x with 1 over cosine of x. And something like this, if it's 2 times 1/2 or 3 times 1/3, where the numerator of the first part is in the same position as the denominator of the second part, they should cancel out, and so yes, it's true that that would equal 1. So that's a true statement, and hopefully this is a little bit of an easier or simpler idea to start with, but that should be a substitution we can make right away. If we look at the next one here, sine of x times cotangent of x, does that equal 1? Can we simplify things in such a way for that to be true? So I look at this and I say, well, sine of x is already pretty simple. I'm not going to be able to change that at all. Okay, that just stays the same. And then cotangent of x, if I look at the formulas I have in that top box, the ones that we talked about already, cotangent of x is just cosine of x, cosine of theta maybe in the formula, but again, x and theta mean the same thing. It's cosine of theta over sine of theta, or in this case, sine of x. And again, this is like having, in the first part, it's like having sine of x over 1. So these things just cancel off, and in the end, I'm left with a cosine of x. Okay, so in this case, this is not a true statement. Sine of x times cotangent of x does not equal 1. This actually simplifies to cosine of x. So in the end, and most of the time this will not, maybe I should have x'd that out. Most of the time this will not work out this way in this unit. Most of the time they'll give us things that are true, but in this particular case this is a false original statement. What we started with here, this is not true. And we've just kind of verified by doing a few simple substitutions that that's not the case. So that's a very quick intro into what this unit will look like. What I would like you to do now, as I erase this, is to kind of get prepared for some other things that we might be looking at. I want you to look at these 6 questions and think about how you might simplify them. Are each of these 6 ideas, are they true or false? Can you go through and do some simple substitutions and try to simplify them and try to figure out, are these things true or false? And if they're true, great, show that work. If they're false, show me where that error might occur. And this will be our discussion that we have in class when